do this, the system is getting show me the pump is running and the indicator shows me it's on, and as well as when you try to visualize here, when I press the start, this one is not energized, but it's showing me, how the pump and the indicator is on, and then the latching system is as well.
Yes, welcome guys to yet another video where I will be taking you through building a direct online starter. And these direct online starters, there are conventional ways of building them, and last time we discussed and we simulated. So by now, if you watch that video, you know how to build a control panel of a direct online starter. But of course, I disown saying buy a PLC and go build a direct online starter. So it's just we are using it for building our knowledge. So right now, here in front of you, there is a program which we could use to run actually a direct online starter with the same power components. We just discard the control circuit and then we use only this. So as you can see, it just looks easy, but every time I bring a program, it has some new basic thing that we have to encounter and its use. So in this kind of a program, a direct online starter, if you go on this control panel, you only have two switches. You have the start and you have the stop. You understand? Those are the only two things you have. So, and if you have those two things, how are you going to do? You just know I have two inputs and two outputs. We have inputs, we have x1, x2, and outputs. You have y0, y1. You can say x0, x1 as well. So the x0 we can say is the start, the x1 we can say is the stop, and the y0 we can say it's the element we're trying to run. It can be a bulb, it can be a motor, it can be any electrical equipment. And then the y1, it's the indicator which is going to be lighting on or off. Yeah, so that's the only program we have. So if I have it connected like this, I have the start and stop connected in series, but I connect the NO of the start in series with the normal close of the stop, because stop is going to only be connected in normal closed way. Any program you're going to be seeing, the stop and the emergency buttons are always connected with their normally closed. The reason, one day if you get it and you're watching this video, give it to me down here. Why stop or emergency button is in normally closed condition? And if you want a video about it, I can make it for you as well, but just give me your idea. We are about sharing knowledge. And then afterwards, when you have the system, when you have it here, I have connected in parallel with this as a y0. Remember, these ones are not maintained buttons. These ones are push buttons, momentary switches. And in one of my videos, I explained very well about momentary and maintained switches. So once you close this one as a button, once you close it and you remove your finger, it's going to come back. And when it comes back, you can see there is no flow of power up to this other end. So when it comes back, when you remove your thumb, you must provide a way at least current should be flowing from the positive rail to the negative rail. So this is the way I have provided. And remember, if I close here and this gets excited, then if it gets excited, you can see this is y0, and I choose a normal open contact of y0, this one will be closed. And once this one is closed, that means power will keep flowing through here, this direction like this, to supply as well as the indicator. And what does this say? This talks about latching. So latching has been the major concept, as in why I brought this kind of a system. So you have to latch, and latching is something which is directly or equivalent to hold on switch. I'm going to make a video about it and I explain it more. It is equivalent to a hold on switch in conventional circuit, control circuits. Thank you. Let me take you through the simulation, and we design the program, we do everything, we meet.
Welcome to the programming session and the simulation session. As we discuss, I have to first go to the comment list and I show you at the inputs. You can see I only have two inputs, start and stop. Then I have only two outputs, that's the pump, the powering of the pump, and then all the on and off indicator. So once I'm done with declaring these variables, I go to my program. The program is as I showed you on the board. I have the start and the stop connected in series, but the stop is normal close. And then outlet goes to the pump and the indicator. Then here I provide the latching. So this program, I compile it. If I compile it, it can show me it is 100% because it indicates no errors and no warnings. Then I transfer it to the PLC. This is when I'm inputting it to the PLC. Now it is to the PLC, then I can run the PLC. Once I run the PLC, I go online. So here it is online. So basically it's done. Like if I press start, it should be showing like the pump is going to run. If I set on and I go online, then for the communication, I have to set this. I normally forget it until it's up to me. So it's enabled. And here, if you want to run the PLC, you can simulate it from here. You see what will actually happen. So if I set this on, you can see the pump indicator is on, and the pump indicator is on, and then the pump itself is on, and here you cannot visualize the push button thing because here I have just set it on. I have to set it off again for the action of the push button to show like it is on and off. But then if I want to stop the system, I now have to go here and I set this one on, so the system will go, then when I bring it back off, it cannot come back. So to visualize everything, I normally like incorporating this to the HDMI. I've already set it up, given the addresses of the start and stop. Then this is the pump, then this is the indicator. I have already compiled, then I just go for offline simulation. So if I go to offline simulation, this is my screen. This is a screen that will be in the remote area where you're going to put the screen for visualization. So I don't know, I have to make this one a little bit smaller, I have to make it smaller, maybe up to here. Then you know, I bring my screen over here. No, Nehi, no, this one, this one. So this is my screen for now. I need it to be in a position whereby we can see everything together. Yep, a little bit here, then I can bring my screen. Yep, here. And bring this one, yeah. So yeah, this is anyway. Let's have it like this. Uh, these are the momentary buttons. I have the start and I have the stop, and then I have the indicator. So once now I press this start, I'm supposed to be seeing this pump going on, and once I press the stop, I'm supposed to be seeing it off and this one as well off. So if I do this, the system is getting it show me the pump is running and the indicator shows me it is on. uh, as well as when you try to visualize here, when I press the start, this one is not energized, but it's showing how the pump and the indicator is on, and then the latching system is as well on. Then also when I come here and I press the stop, it stops, it shuts down the system, you can see. So this screen of mine, I pray it with a start and stop. The pump is on, the latching system is working well, and we have the communication. Once I press stop, you just watch this button here and this one. Once I press stop, this one gets, that momentary move. Once I press start, you just watch this together. It will just show on and off, but the latching will continue. You see? That's how the system is going to be working with the PLC. At least you have known latching, you have known how the system can operate. And once you want to learn all these things, because these systems, the SCADA systems you see out there on the softwares, you have to design. I come up with this, each and every element. I come up with the right images for the pump, the right images for the starter and so I'm the one that makes the selection. So the human machine interface, it's you, the designer, that has to come up with it. But this one, first forget about it and we concentrate about this one because this is the basic. You can become a PLC designer when you only know how to program this and you leave the HMI. So thank you. We meet in the next video and I'll be happy to meet you there.